Hello and welcome back to this CMEMS presentation of the new NetCDF to QGIS plugin developed by Novelties for the Copernicus Marine Service. In this second part, we are going to see more advanced functionalities of the QGIS plugin. Here we are going back to the NetCDF tab here, and we are going to import two model and observation products which don't have the same resolution. So we are going to select an observation product of sea surface temperature here, and also a model product of sea surface temperature on the month of April, the 15th of April. Here. Click on Open. Now we are going to add the first layer corresponding to the analyzed SST variable. So we don't have to select any time frame because this file is containing only one time frame. Click on Add and Close, and go back to the NetCDF file list, and you can select the global model product, select the sea surface temperature variable, and add it to your QGIS project. Selecting Add and Close again. If we go to our QGIS project here, we can see that I'm going to hide the previous layers. Here we can see that the observation sea surface temperature and the modeled sea surface temperature don't have the same geographical extent, and if we go to the NetCDF to QGIS plugin, we can see on the metadata that the observation has a 0.05 resolution and the model SST has a resolution of 1/12 degree. So if you have variables and products that don't have the same resolution and the same geographical extent, there is an option in this new plugin to align your rasters in order to have grids which are corresponding. So if you select your two SST layers we just loaded, here you can right click, select the two layers using the control key on your keyboard, and you can right click on the layers and select Align Raster. Here we can select the reference layer to align the second layer too. So we are going to align the two layers on the model product here, which have the coarser resolution. Once it is done, you can select here your output directory. Once it is done, you can select the align option here, and here you have a new layer corresponding to the observation layer here, but aligned on the model product grid. If we go to the QGIS project and we compare the observation product aligned and not aligned, you can see that there are some modification at the coast. And if we zoom to the layer, we can see that the resolution at the layer is not the same, because this observation layer had been modified and in order to correspond to the observation and to the model layer. Here we have the model layer with the coarser resolution, and here we have the new aligned analyzed SST layer corresponding to the model layer. So this is a good option to make your two layer corresponding before applying some modifications and some operations with a raster calculator tool. If you want to make a difference or other operations between two layers. A second advanced option of this plugin is the option to display vector fields. To do so, we are going to import a new file, a new netcdf file containing eastward and northward seawater velocity. Here is the new netcdf file containing the two variables at a 112 degrees resolution from a global model with a monthly mean temporal resolution. Before drawing this vector field, we are going to hide the two layers we have aligned before. So you can select the three last layers and click on Uncheck in QGIS to hide these layers. Here, if we go back to the netcdf file containing U0 and V0, we are going to import and add each layer to the QGIS project. So we are going to select the layers on the month of October. Click on Add and Close. You can do the same for V0. Add layer, October, and click on Add and Close. And here on the background you can see that you have your two layers imported. If we go back to the plugin, we are going to the Layers tab, and here we are going to draw a vector field of these two components, eastward and northward seawater velocity components, to have a vector field and not scalar fields corresponding to one to the U0 variable and one to the V0 variable. So you select your two layers by pressing the Control key on your keyboard, right click on the two layers and select Vectorize. Here you have several options. You can select the UV components because we are using a component for the eastward velocity and a component for the northward velocity. Load the layers corresponding to your components, and here we can change the norm because the norm is not the same for currents and for wind and waves, so we are selecting currents. We are going to apply a downsampling, which is a ratio selecting, for example, if I select a downsampling of 10, it's going to display one vector out of 10 on my grid. So I select the downsampling of 10. I can change the output directory, but by default it's the output directory I've put on my option window at the very beginning of the Siemens demonstration part 1. And here I can change the name of my vector layer. So I'm going to select October and 10 for the downsampling. Here you can click on Vectorize to compute the vector field. If you close this window and hide the V0 and U0 scalar layers, you can see that the vector field of oceanic currents is displayed, and it's clearly visible along the South American coast. Here you have still access to the properties of these vectors. So if you go here to your layer of the vector field, you can still go to Properties, Symbol, and change. For example, if you want to reduce the size of the symbol, change the size, click on OK, apply and OK, and the symbols are smaller. So you have several options of downsampling. If you go back to vectorize, you can change between 2 and 100 to select the downsampling which is the best to the representation of your vector field. So that was a presentation of two advanced functionalities of this NetCDF plugin using Copernicus Marine Service data. All the information on how to use this plugin are gathered on the user manual that you can download with the plugin following the link on this video. Thank you for your attention and goodbye.